So later, the people who will not be able to join our classes, then they can always join. So today is the introductory class. If you cannot listen or if it is lacking from my side, so you can always ask me, then I'll switch to another network. You understand what I say? You have to.
Yes,
you have
sir,
to
sure.
Say, yes, no, very good, etc. Okay, this is the part one, introduction. If you look at here. So this is the introductory things. First of all, we shall try to understand what is power electronics and what are the main components of power electronics. Okay. So from the chapter one, power electronic system. So if you look at this one, so let us try to understand what is power electronics. When you will be, okay, like, I think it is better to use the whiteboard rather than to use the book directly. Can you see the whiteboard now?
Yes, sir.
Yes, sir.
So it would be like your blackboard in your or the whiteboard in the class. Let me write down. So I'll set. So this is introduction. You should have your pen and paper with you, but use a class note like thing, class khata. That will be very easier for you to understand the thing. Okay. So I'm now drawing a basic block diagram. Basic block diagram. Power electronic system. So the main component of the power electronics is the power processor. Actually, we shall study this part. So power input will be here, and then this is the input current and input voltage. Usually, we shall take this voltage from the utility. So that will be your power output. And suppose this is your load. And from the output side, what we will take? We shall take the feedback signal by measurement. Measurement means there should be some
Feedback.
Sensor. The sensor will send the signal from the output, and that will be reference or command we say that will be given here, and the controller will give the control signal to the power processor. Control signal that will be given to the power processor. Okay, now usually this input side, if you look here, this is this input side. That power input will be from which source of the sources of power input. Can anyone tell me what could be the power sources? Hello. What will be the power sources? Can you hear me?
Generator.
Battery.
It could be
First, I have told you utility. What does utility mean? Utility means in our country, like your REP, say PDB or PDC, all those things, PDC. So these are the people they provided the power. And even if they, in some areas where we use this power electronics thing, power input could be from the different sources. What could be that sources? Can anyone tell me? Hey Nadim, Sabiq.
Sir, can you repeat the question again, sir? Sir, I missed
The
the question.
question is that other than the utility, what could be your power sources?
The solar.
Renewable, right? Renewable energy.
Solar, sir, gas generator, diesel generator.
Yes, sir. Generators and batteries, sir.
Yes. Or other sources like generators or batteries. Yes. So the power input will be from either utility. So that is from the utility in our country. What is the single phase voltage?
220.
230. 220 to 232. And what is the frequency?
50
50
hertz.
hertz.
Yes.
Okay, and say renewable energy, of course, it is not always sinusoidal, maybe DC, or maybe mostly it is actually DC, and from that DC we process the power. So what is the main task of the power electronics? If you don't understand, if you don't hear, then you can always tell, sir, okay, please repeat, or we are not understanding this thing. So what is the definition of the power electronics? The definition of the power electronics is that it is a system which processes the power. So what will be the definition? Power electronics. Electronic system. The target is to process the power. Process the power. Okay. One. So our power is already available. So why do we need to process the power? Is there any answer for this one?
For efficient conversion, efficient use.
Actually, not that.
Make it DC to AC.
Users.
To
Yeah,
get the digit parameters.
Yes, exactly. The users, they are not necessarily they want to use your 50 hertz 230 volt power. They may want to use the, say, DC voltage. They may need your variable AC voltage. They may need the variable frequency AC voltage. You understand what I say? Suppose you want to control the speed of the motor, then this fixed frequency and fixed volt is not sufficient. You have to process it. to meet the demand of the user. So the task of the power electrons to process the power to meet the demand of the user. How? To control the, how you will do that? How will you process? What is the
different parameters.
modality? To control the flow of electric energy by supplying voltages and currents in a form that is optimally, not efficiently, optimally suited for user loads. You got the idea? We have to process the power. How? You have to control the flow of energy. The flow of energy could be reversal, it could be reversal, but in general, it should go to the input to the output. But sometimes from the output, you can feed back to the system also, regenerative. Anyway, you will control this flow of energy. How? You have to supply the correct form of the voltages. Like if it is a DC motor, you must, this one will be a DC. If it is a AC motor, it might be AC. If it is a variable frequency AC, then you have to make it AC. Okay, so you have to, there will be a controller or brain. So you will tell that, okay, I need this voltage, reference voltage, this reference voltage, this reference frequency. Then you will tell that thing to your controller. Controller will tell the power processor, okay, you process my power this way, and then it will be processed, input will be taken from the utility or any other sources, and it will be processed. And this power will be also in the form of voltage or say current, voltage, current, or sometimes speed of the motor if it is a load. So this will be a V0, and this is say I0. That will be sensed by the sensor. Sensors will sense this, and then that will feed back to your controller. So your reference or comment, what you want, that will be given to the controller, and your actual feedback will be taken, and that will be compared. If the controller, if you are a controller, human controller, if he says that, okay, to run the motor at 1500 RPM, I need a DC voltage of say 200 volt. So if this 200 volt is here, then so you want say 200 volt corresponding to 1500 RPM. So that you want. But if this is 200 volt, okay. If it is not say 210 volt, it is greater than 200 volt, then the error will be calculated by this controller, and he will tell the power processor, okay, you please give the load less than your 210 volt because my user want 200 volt. So then he will do something. Actually, what the processor will do, that is our topics to discuss. There will be a lot of electronic devices, power electronic devices. Power electronic devices, I will come later. So, as for example, I can tell you that some of the names like diodes, then your transistors, BJT, MOSFET, IGBTs. Then in the thyristor series, you have the SCRs, you have the TRIAC, you have the diac, all those things. So we shall use these devices in the power processor, and of course these devices will run as what? Oh, it has gone. Okay, let me take.
Switching devices.
Yes. So this device will not work as in the power processor. This device will not work as an amplifying device. Rather than what we will do, we will just turn it on and off. So devices used in the power processor will be operating in the on off switch as on or off switches. Now question to you is that, okay, so suppose there is a transistor, or there could be a diode, or there could be MOSFET like this. There could be IGBT. So we shall use this one as on-off switch. How for as far as okay diode, how the diode will work as a switch? Can anyone tell me how the diode will be working as a switch?
When it is forward bias, it is closed. When it is reverse bias, it will be open.
Okay, so then the diode will fully controllable by the application of the voltage, right? You
Yes.
cannot turn it on and off by your own. Suppose this is a diode here, and you are applying an AC voltage here. So, so this is the VS input voltage you are applying. This is the say yes, this is your VS. And since look here for the positive half cycle, if this diode is ideal, so it will be just simply turn on during this period. So on the output side, you will get this one. And for the negative half cycle, there will be no flow of current, so you should get a 0 voltage. You understand it or not?
Yes, sir.
Yes.
Yes, sir.
This is a simple thing. So for this diode, it will be turned and off by the application of the voltage. And you cannot do anything from the outside. So this type of devices will be known as uncontrolled turn on and uncontrolled turn off. So this is the diodes, the example of this one. Okay. And there will be some other devices. Okay, so this is the basic block diagram of the power electronic system, and I have already introduced it. Okay, if the sometime I make a question like this, if sensor does not work properly, then what will happen? If sensor, the sensor for sensing the output voltage or output current, if they don't work properly, then what will happen to your power electronic system? So it will malfunction, right? So
Not get the required output.
Right. Actually, say the voltage is 230 volt, but it is giving 190 volt. The sensor is giving. So then the processor will give more power to your load, and then motor will run more than the reference. So the system will simply fail. So sensors are very important, and also controller is very important. And with this sensor and controller, the power electronics devices will be turned and off. That will be set by you how it will be turned on and off. Okay, instead of using, if now we use a transistor. Suppose this is a transistor, and we want to use it. Suppose this is your VCC, this is your ground, and this is your say C, and this is your P. So, okay, from here we are taking VCP. This is your VCP. So this is your RC. If we want to operate our transistor, okay, let me draw the characteristics curve. And this is your IC. So, are you familiar with this figure? Because you are the master's student, you should be able to know. So this is for the different value of the current. Suppose this is for the IP equal to 0. This is greater than 0. This is your IB2. This is your IB3. And this is your IB4, and so on. This IB1 is less than IB2, is less than IB3, etc., etc. Okay. Now I want to make our what is the region. So if it is 0.3 volt, and if it is 0, suppose this is say 1 volt, this is 2 volt, this is 3 volt, so on, all this thing, maybe the large voltage will be maybe say VCC. This will be say 12 volt. So this portion when the VCE equal to 0.3 volt or say maybe 0.2 volt. So this region will be known as what? Saturation region.
Saturation region, sir.
Okay, so this region will be known as
Saturation region.
or saturation region. Saturation. And what this region?
Cutoff region.
This is your cutoff, right? Cutoff. And rest of the this region is your active mode.
Active region, sir.
So for the power electrons, we will never use this in the active mode. Either will be in this when your IC will be 0, or whether your VC will be very small, which will be taken as 0.34. Okay, if you apply your say it will be always 0.7 volt because this is your base and this is your collector. Based emitter will be forward biased, and if the collector base junction is the reverse bias, which is it is active mode. If it is also in the forward bias, so we call it the saturation. Okay, and the lowest value VCB could be your minus 0.4 volt because this is your NPN transistor. NPN transistor. If it is negative means you are making it forward bias. You understand it or not? These are the basic thing of from the undergraduate. If this voltage is VCB voltage is negative, that means you are making it saturation. And if this VCB is greater than minus 0.4 volt, we are still in the active mode. But you have to make it more negative, minus 0.5 volt, okay, minus 5, say 5.5 volt or something like that. Okay, so the boundary condition, if we put that one, if we apply the Kirchhoff voltage law, we see that VCE will be your negative, positive, positive, negative, then minus VCB, and then positive, negative, minus VBE will be 0. So VCE will be your VCB plus VB, right? So this is your 0.7 volt. And VCB, the limiting value is what I told already, minus 0.4 volt. So saturation voltage is actually 0.34. You understand it or not? Hello?
Yes, sir.
You should. So, and what we will do, we will operate our transistor either in the cutoff mode, then we will take the current will be 0. And if the current will be 0, IB equal to 0, then your IC will be also 0. Your IE will also 0. Then what will be your VC? Can anyone tell me what will be your VC? Like Kirchhoff voltage. So VCC, and there will be no drop here. So VC will be VCC for the cutoff. You understand it or not? Hello?
Yes, sir.
You apply your Kirchhoff voltage of this way. Okay? And when it will be in the saturation mode, I have already told you this voltage will be your say minus 0.4, and that will be your 0.3, and which will be your initial take 0. That means this one. So look here, if you operate in the cutoff mode, so your current will be 0, IC is 0, so power across the junction will be almost 0. And also in the saturation, when you are in the saturation mode, the power across your junction will be your say IC multiplied by VC is very small, say 0.3, and the current may be say okay 100 ampere. So since it is very small, may be taken as 0. So also in the saturation, the power will be 0. And but you will be switching to saturation and cutoff, right? There will be some transition, very quickly if you do that, and there will be some switching loss. We shall discuss all these things, inshallah. If possible, I shall give the introduction today, maybe next class. Okay. So by this time, you should be familiar with the power electronic system now. Let me again come back to your. Can you see the book? Can you see the book?
Yes, sir.
Yes, sir.
Okay. Now, in the power electronics versus linear system. So power electronics thinks at least what is the difference between the power electronics and linear electronics? You should be readily saying that in the power electronics, the devices will be operating in the saturation or cutoff, and the linear electronics, what we have already learned, it is in the amplifying mode, right? Am I correct or not? And in the amplifying mode, what is the highest power you can transmit as the amplifier class A, class B, class AB? Can you remember that?
90% with class C type amplifier.
Class C actually.
D, sir, class C.
Class AB. AB is the basic amplifier and the highest power.
78.5.
73% or 73.4%. Rest of the power will be lost as a heat, and then you see that if you want to operate or handle high power, then suppose you are handling 1 megawatt. So 25% of 1 megawatt, what will be 0.25 megawatt? And can you do that by linear electronics? It will be high loss and it will be lost in the form of heat, and then you will need probably sufficient water to throw it over your devices, right? That is why we need to use the power electronics concept over there. And the other thing is that also, since you are not using, you are using power electronics, since the device losses is less, so you don't need very heavy heat remover, which is known as the heat sink. So light heat sink is needed in the power electronic system rather than the linear electronic system to convert the same amount of power. You have to mention, it's like you are transferring 10 kilowatt. If you do that thing in power electronics, the loss could be of say 2% or 5%. But if you convert this one in the power linear electronics, you 25%. So this system is less efficient. Linear system is less efficient than the power electronic system. All these things it is also written here. So in the Harun Ar-Rashid book, you can have idea. And this is very interesting figure now. If you look this figure, okay. So look here, it is very important. So you are taking the power from the utility. Can you see that? Can you follow my pen? So it is mentioned this is the line frequency transformer. What does it mean by the line frequency transformer?
50 Hz transformer.
So yeah, that means that it will convert the power in 50 hertz. Okay. So low frequency and 50 hertz is a very low frequency, and this is the generic form of showing the rectifier. So it will rectify and you will get a say rectified wave like this, and then you will a capacitor here. So this voltage will be converted to say this one will be converted to like DC, pure DC, and then what you are doing, this is nothing but a transistor will be used in the linear range. Suppose this is your say VCE and this is your say IC, and you are using the here different slot. If you use here, and then it has a different slot, I and V. The relation between I and V in the linear range is nothing but the resistance, right? You know that linear length. So if you operate this one here, then you will get one resistance. If you operate here, you will get another resistance. But since the transistor is working as a resistor, then what will happen? there will be power loss, right? So this is nothing but the, like the rheostatic, the DC voltage is applied here. So you will change the operating condition. That means you are changing the resistance. If you change the resistance, of course, you will get a variable voltage here. But since the transistor will be operating in the linear range, a lot of losses will be there. You got my point? Hello?
Yes, sir.
Yes, sir.
If not, then you read it. Okay. Now, if you go to the next figure, you will see there is nothing but the division of the output. So VDT is nothing but the voltage from, you can see the voltage here. This is your VDT. And they said that, okay, there could be a range of the voltage here. So, look here. So this VDT, depending on the input voltage, actually, input voltage may change. So it may go higher voltage like this, because we have already rectified this one, and lower range will be like this. And then they have already taken the integration over one cycle, maybe this one. You know the how to find out the DC voltage, right? 1 by pi, then 0 to pi, then the voltage VDT, dt, and if you integrate this one and divide it by the time period, then you will get the DC voltage easily. So they will find that this voltage is there. And then so these are the things they have written here. And in the practically what we can implement that one, and we see that if we change this voltage here like this, because of the input of the change of input from the utility, we'll get this kind of thing. Okay, now if you do the same thing by using the power electronic system, then you can design a circuit like this one. So look at the utility supply. We have not used any transformer, because if you use the transformer, what we have used in the linear system, the previous figure was the example of the linear system. And then we use the transformer, and then it will add your additional cost. And not only that, because of the low frequency, your filter element will be heavy. So what is the relation between the frequency and the filter element? If you use the low frequency, then your filter, like the capacitor bank, will be very heavy, and also the inductance will be very heavy, and it will incur your another cost. But if you do the same thing without the transformer loop, this is the power electronic system, and we did not use any line frequency transformer, rather we have directly used this one, and then we have used the capacitor. And what we have done then there will be winding of the high frequency. So this is the transformer. There will be two winding in the primary, and then one ending in the secondary. So when the voltage is positive, then that will go this way, this way, this way, and then your power electronic device will turn on here by using your control signal, and you take the feedback here. Then in the negative half cycle, and then you will see that it will go from this direction, and then we will get a high frequency here, and that will be transferred here, and then that will be again. We shall use now again another rectifier here, and then the output of the rectifier, we can have the low pass filter, and the filter element is very not that much heavy that we have used in the linear system, because we have already made the high frequency transformer. So because this voltage from the input side will go to the primary to secondary, will be high frequency, will be with the PWM type things, and then it will have, you are taking the DC voltage, but you are chopping this one with the high frequency, okay? And that will be, again, suppose this is this thing, and then it will be rectified, and then finally you will get the rectified output. So we can see the rectified output, what we have done. Let us see the next figure. So this is a simplified diagram of this one. So that will be easy to understand for you. So this is the VD voltage that we have got from the line frequency rectifier, and then we were turning on and off. When it will be turned off, then look here, this diode will be off, and then you will get the voltage. The AC will go there, AC ripple will go there, you will get only DC, and then will come back, right? And from the you will just turn on and off. When it will be turned off, then it will be like this. This will be not there. You understand that? When it will be turned on, it is short circuited, and the circuit will be. I am going a little faster because I am really very tired. Okay. So now it will be like this. Okay. It will be like this. So this is your filter inductance. This is your filter capacitor. So you will get the voltage constant. And when this switch will be off, then what will happen? This is not here. Your circuit will be the current will go through. It will go through this. Only your circuit will be shorted, and then this one will be this one, and then this. So if you now analyze this one, then if there will be some buck boost type regulator. So we shall study all these things again later. And finally, what you will get, I am just skipping this one because these are the basic thing. Probably if you read it and understanding it, and that has been given here on and off the same figure, and finally you will get the voltage here. Can you see that V0I? V0I is the voltage from here that is filtered, that has been applied to your filter. So when the switch is on, so it will be like this. What I have mentioned, that the output voltage will be simply your VD, that is this one. And when it will off, then you will not get any voltage other than this V0Y will be shorted, and you will get this one. So this is the like a chop of things. We have already studied this thing in the undergraduate level, and if you integrate this one, then your V0I, that means the what is this? The DC voltage will be your V0I dt, and this is replaced by your say this will be V0I and I DC voltage, and then finally you will get this one. That means V0I multiplied by T1 divided by DS. So this way you can always get your output voltage. Finally, the ripple, what is there? That ripple has been shown here. Ripple, and if you now take the harmonics analysis, and then you will see that you will get first harmonic, second harmonic, third harmonic, fourth harmonic will not be there. Fifth harmonic, sequence, seven, because if you do the Fourier series analysis of this one, then you will get this kind of thing. So please read carefully this one, because the problems are here at the end of this chapter on this figure, and I have the solution also with me, and after you have already the solution manual with you. If you don't have that, let me know. I'll give you, but not at the first time, but later that will be good. First, you have to try by yourself. Okay. Okay. Then there are some of the scope and applications. So if you go to study this one, so this is the main application of the power electronics nowadays. That means SMPS. What is SMPS? Switch mode power supply. That means you are that thing. Nowadays, switching mode power supply are being used in the computer. They've been used even in the LED light. Even you are using in the laptop. You are using in the camera. You are using where not the switching mode supply, and also in the charger for your mobile phone. That is also your switching mode power supply. Switching mode power supply is nothing but that we shall apply the DC voltage, and then we will chop it, and we will regulate it by your own target and we have the feedback, and then the reference will be there. And if there is any change of the voltage, because so as for example, if you use this charger from your AC supply, if there is any change in the AC supply, you look here, you are always get a fixed voltage of 3.5 volt for your mobile charger. So this is the one great application of our system, and then this is the energy conservation. What does it mean by conservation? Conservation means that we want to conserve the energy. How? There is an example they have given in this book. Hey, undergraduate, I have already taught these things, right? ITM?
Yes, sir.
Can you remember or you forgot? So look here, there are two pumps here. This pump is just conventional drive. So it takes the power from the input, and motor is connected to your pump, and it is supplying it. It does not have any control system whether you need the less discharge of water. But if you have an adjustable drive here, so you will take the feedback, and you can always control the discharge of how much water you really need. So this is, and also if you nowadays, if you go to the any factory, you will see that all the process control or everything is done by a single computer, maybe main computer, and operator is just sitting in front of the monitor, and he is controlling all these things. And also in the transportation, now electric vehicle and electric train is already in the system. In Bangladesh, they will be using after 2 or 3 years. You will see Metro Rail, they will be using this one. And also, you mentioned, okay, electric have been widespread used for a long time. And also the electric vehicle. Now the hybrid vehicles are much more popular, and it is telling that after 20 years, all the petrol or the octane vehicle will be replaced by this electric vehicle. And Tesla, they have invented one car. So once you charge, then you can run your vehicle more than 300 kilometers. So maybe within a very short time, your battery capacity and power electronic system will be improved, and you will get much more efficient electric cars or electric vehicles. And there are also the electro-technical application. Electro-technical application means that, say, welding, electroplating, induction. Induction heating is very, very nowadays popular. You know, the induction heater, people are using this thing. You don't need to connect the heater. Heater, loss of energy process in the form of light, and also now that electric bill is high, now induction are available. And also utility related things are like, are you familiar with the high voltage DC transmission line? Hello, are you sleeping?
No, sir.
No, sir.
We are not sleeping.
Okay, this is your power plant. So you just make it high voltage, yeah, transmission line, and then use rectifier here. Rectifier. Then you have the only one line grounded, and this is the DC, and the end and sorry, this is inverter. And with that one, then you may have three-phase line, three-phase inverter, and this from the ground you can take it. And the three-phase line, you will have another complete the transformer, and then you can just, this is the high voltage DC transmission. The improvement of the why we want to use the DC one, because less loss, capacitive inductive effect will not be there, and also the corona effect, you know that. The high voltage AC, the air around it will be ionized, and there will be some losses over there, and that will be minimized. So these are the main application of the power electronics things. If you should go through that. Now we can come to the power processor. I shall just complete this chapter 1 today because very much time. Okay, so what are the power processor in the power electronic system? I have already give the this is your power processor. I have already given the idea of the power processor. This is your load. This is your output side, and from that feedback is there. This is your controller, and this is your reference. This is the input. So inside the power processor, what it could be, or what is the purpose of this one? Depending on the application, the output load can have any of the following parts. DC. If you want to have AC to DC, then it is known as the rectifier. We have two types of rectifier. One is uncontrolled rectifier. Uncontrolled, another one is the controlled rectifier. Uncontrolled rectifier, we shall use the diode here, and the controlled rectifier, we shall use the SCR. Are you familiar with the SCR? Hello.
Yes, sir. Yes, sir.
So we shall use this one. And these are the syllabus, of course. We shall go details of this thing, inshallah. And if the output is AC, then what you will get? So we have to make the DC, say AC to AC, like your regulator, fan regulator, all these things. Or if you want to have adjustable frequency and adjustable magnitude, then you have to make it AC to DC first. Then that DC you can use to as the inverter to you can make it variable frequency or you can make it variable amplitude. I don't know whether you are getting it or not.
Yes, sir, we understand.
You must understand that. But
Yes,
inside
sir.
inside the power processor, then not necessarily only one converter is there. You may have, as I already mentioned, you may have a rectifier here, rectifier. Then you may have an inverter here, and here some of the energy storage element, that means the capacitor or inductor could be here. So this is that. So if you now go, sorry. Here. So there, as I already mentioned, there will be several types of converter. This is the converter I have already mentioned to you. Here, you can use multiple converters. So the converter could be AC to DC, that is rectifier, DC to AC inverter, and DC to DC chopper or SMPS, switch for power supply, and AC to AC is the voltage. Okay. Mainly we will concentrate on the AC to DC and also DC to AC and DC to DC. This AC to AC we have already learned in the undergraduate level. Have you heard the name of the cyclo converter?
Cyclo inverters.
So actually, cyclo converter, you can change the frequency step by step, not too smooth. Multiple from the 50 hertz, you can make it 100 hertz, you can make it multiple, right? 50 multiplied by 2 multiplied by 12. So in the AC to AC converter, you can use that one. So you can have all this idea. And in some of the cases, inshallah, we shall use some videos also from the YouTube. I collected and downloaded and showed. Okay. So we have almost finished this chapter. So you look here, there are some problems at the end of the chapter. So you should go through this one, and at least you should solve 1, 2, 3, and 4. Will you do that? I may set question in the midterm. So you please practice these things, okay? And inshallah, next class I shall give you assignment. I will try to give you assignment. But we are highly loaded. The faculties of the IoT, they know that how much loaded we are in this online classes. And this is really very trouble for us. So in the chapter 2, actually, there are some devices like your diodes, thyristor, and controllable switch they have given you. You just read it, it will not be set in your exam. You can have some idea, okay? These are the basic things you have already done. But inshallah, in the next class, I shall start from here. So, I'm very sorry that I could not continue because I am almost 59.